Responsible AI is a big topic itself. With today's focus, it's going to be about fairness technologies. With today's agenda, we're going to start with a little bit of game. Any of you here like playing games? Yes? Yeah, a lot of you. And we'll dive into some of the background like bias in our society before we talk deep into a technology side of things, and then we'll talk about the conclusion. Today I only have 30 minutes, so I might have to skip some slides, so bear with me. You can take pictures for some of the slides if you have to. And with that, are you ready? Yes? Okay. Tell me what's the first thing you see, okay? So you can just yell. What's this?
Old lady.
A lady? Any other answer? Young woman?
Younger lady with a feather in her hair.
Okay, good answer. How about this?
Rabbit.
Rabbit. Rabbit, only one answer? Dog? Two answers. Rabbit? Okay. How about this one? Saxophone player. Any other answers? Saxophone player? No? Okay, two answers. How about this one?
Frog.
Are you sure? A horse. Somebody see a horse. Yeah. Okay. So what's the right answer? What's the wrong answer? I think this little game tells us that we all have our own bias. We all have our own ways of seeing things. It's not necessarily a bad thing. Right? It helps us to understand the world very, very quickly. So, but then understand this bias in us, acknowledge them is very, very important. Okay? Bias is there in our society. And this is a topic we've been talking about for many, many years. We know we have bias unconsciously. Unconsciously, if we make decisions based on this bias, it can cause problems. So here are just some of the steps you can use to address the bias issue. So I'll categorize this into 3 categories: identify, explain, and mitigate. Okay, I think some of you might be a bit confused. Why are we talking about this? This is a human society. We are here. This is data.com, right? But anyways, in the human society, we proactively address the issue by using techniques such as affirmative action. So affirmative action is not about we prefer certain gender or race just because women's better or men's better. It's more about we proactively trying to close the gap in between the privileged group and the underprivileged group. And I show an example here. This means that in order to do that, we have to take proactive actions, and we might have to collect those sensitive information for us to do that. For example, in order to make sure we hire enough women applicants, we actually need to know their gender, right? And why are we talking about this? Why do we care about this in AI? So here's a problem. AI systems, we are starting using them to make decisions. We are using AI systems to change people's life, to make human decisions. We decide if we want to hire this person or not. We decide if we should give this person mortgage or not. What if your AI system is not fair? What happens? If you have an AI system that's telling you things that's biased. So that's why we're talking about the topic today. We can't just talk about this in the human society. We can't just talk about bias in human. We also need to talk about bias in AI. There's a famous case study. So with the Compass software, it's a software that previously, when they designed it, they're actually trying to help to address the issue with bias in human. So they're like, what if we just develop a software that's not biased, right? Because software is machine not supposed to have bias, right? At first, that's what they thought. It turns out in this case, the software they build that, unfortunately, is discriminating against black defendants, and they think they are more likely to be violent again, and they should be in jail more than white defendants. So what's the solution? We know that's a problem. We know we cannot let that thing happen. Some people might say, what if we just, when we train the model, we just don't tell the model the demographic information, such as gender, age? Is that going to solve the problem? Do you think it's going to solve the problem? Yes, no? No? Yes? No? Okay. And that's why we are talking about this. I'm going to tell you why it's not enough. To talk about that, here's a little background. If you work with machine learning, you might have heard the terminology protective variables. Basically, protective variables, they are just sensitive variables that are associated against a law to discriminate humans based on these characteristics. Machines should not do the same as well. That includes age, gender, disability, sex, religion, and so on. One solution people think that might work is to remove the protective variable, right? Because the assumption is we don't tell the machine this information, it's just going to be fair, right? But here's the problem. There's such a thing, we call it proxy variable. Without having to tell machine learning those protective variable informations, there is such a thing called proxy variable. That is that it helps the machine to learn those protective variables without you specifically tell the machine. For example, if I see your resume and it says, you graduated in 2020, then it kind of reveals your age information, right? So those are called proxy variables. We need to identify and take consideration into those proxy variables as well. This sometimes can be challenging because you might not necessarily know what the proxy variable is. It's another case study. I don't know if any of you seen this on the news before. Amazon, previously they built a recruiting system, and they're like, hey, this time we're gonna do it right. We're going to remove all of those protected variables like gender information, all those demographic information. They're like, oh, we just remove those information. So they're already trying to build a very fair software. What happened? In this case, eventually Amazon had to stop this program because they realized their machine learning model is discriminating against women. As long as it says anything that can indicate that the applicants are women, it downgrades the resume. That's a huge issue. And some people might say, well, it's just statistics. Women are just bad at math. That's true. It's not just statistics. Something led to those statistics. I remember when I was little, people who loved me, including my grandma, would tell me, girls don't need education. I have a hiring manager who hired me told me that women's just not good at math because his sister's bad at math. So those are the information we keep getting, we keep hearing since we're little. So statistics, they are not just statistics. Something led to those statistics. And which is the reason previously we talked about affirmative action is important to proactively address this issue. The same in the human society and the same in the AI system. Okay, so those are the bit of background why this is important and the reason I have to talk about this. The next few slides, don't worry if you don't understand some of the technical terms, just know that these are important concepts and you can always look into them later. The first thing I want to talk about is data bias. Okay, you don't have to memorize this. I didn't memorize any of this. I read the paper though. But the point of this slide is there are many types of data bias. So you can always assume that there's some kind of data bias there. instead of assuming there's no bias, you almost always want to assume there's probably some kind of biases, so let me look into those, okay? Why do we have to look into this? Because if you have data that's biased, you are going to build a biased machine learning system. But when your machine learning system is biased, it's going to cause harms. There are two different types of harms. One, allocation harms. That's why I was mentioning when you use AI system to make decisions of people's life, we should hire this person or not, if this person we should accept them into school or not, if we're gonna accept the mortgage application. It can cause harm. Imagine if the AI is biased against you because of your gender, because of your age. The other type of harm is called quality of service harm. So this one, maybe it's not as serious as the first one, but it's still an issue. If you pay the same amount of money as your friends, your coworkers, on an AI system, let's say it's just manga AI system. You can play with the games with some AI system, and what if it only works for a certain gender, a certain race, certain age? It's not fair, right? So this is called the quality of service harm. We don't want those harms to happen. And it's important for us to understand this bias, because when you have bias in your data, your machine learning model is going to learn those bias and can compound and exaggerate those bias with the proxy variables we previously talked about. We have to stop this feedback loop. If you have bias in your data, you are going to train a machine learning model that's biased. And then the machine learning model is biased, but if you don't care about it, you're going to take action on it. For example, if I build a model that's biased, that's racist, and my model says you should put black people with like longer jail time, and you take action on it. You put black people to the jail for longer. Those are going to become real world data. So when you train your machine learning models, you put those data in there. Oh, black people have longer jail time, so we should put black people in the jail for longer. So that becomes a really, really bad feedback loop. That's why we need to stop this. Does that make sense? No? Yes? Yes? Some people nodding? Okay. Don't panic, you don't have to memorize this. Thankfully, in the AI world, people who focus on this area, they're looking at some fairness metrics. So there are many metrics, you don't have to memorize them. Demographic parity is one that you might see them a little bit more. Equal opportunity, equal odds as well. The point is there's solution. Not necessarily it's a perfect solution, but fairness metric, you can use them as to evaluate if there's bias in your data, your model. You can also use them as constraint for your models. So this is one of the techniques a lot of companies are using when they build their AI fairness tool. This fairness metric we can categorize them into group fairness and individual fairness. Group fairness is about you wanted to treat different groups equally. Right? You want to treat women and men fairly. So group fairness matrix helps you to determine if your model is treating different groups fairly. There's also individual fairness metric. It's about given similar prediction outcome to similar individuals. A lot of our open source toolkits focus on the group fairness metric, not necessarily individual fairness, just because it's harder. But at the end of the world, we individuals, we care about all individuals, right? It's not just a group of people we care about every individual. Okay, not too bad, not too technical here. Okay. So there's some technical approaches with some open source toolkits. Previously, we talked about steps to address the unconscious bias in human, identify, explain, and mitigate. It's very similar in the AI world as well. You want to identify the protected and proxy variables. You want to be able to explain them so you can augment your machine learning solutions to take consideration of these bias issues so you can build a model that's fair. Communicate is also very important, and we'll talk about this later. How much time do I have? Okay. So identify. Identify data bias. So this is before you build a machine learning model. This is either very easy or very hard. This is similar to the affirmative action we're talking about. In order for you to know if you're a recruiter, in order for you to know if you are hiring a female, you actually need to know people's gender, right? So this is the same thing. If you have access to proxy variable, it's a lot easier for you to just calculate the statistics, and you can understand if the data you collect is biased or not by calculating those statistics. But if you don't have access to those variables, good luck. And that's another reason communication is important, and talking to your client, talking to people why you need to collect those information. It's not like you are trying to build a model based on these characteristics to discriminate people. It's about those characteristics, those protected variables. Helps you to understand and to evaluate if your model is being biased or not, and if there's bias in your data or not. There's a toolkit, AIF 360. This one is from IBM, I believe. They have some toolkits that can help you to identify some of the data bias. I'm not gonna dive into this. If you are interested, just Google AIF 360 and you can learn a lot more there. Identify model bias. Previously, I talked about the demographic priority. So DPT score is a commonly used fairness metric for you to identify if there's model bias or not. This plot is from Microsoft FairLearn, so you can use some of the open source toolkits like FairLearn to identify if there's model bias by evaluating the DPT score. Explain, the next stage. The next stage, explain is also very important. So explain is about if you understand why is your model biased, what kind of features your model is relying on to make those predictions. Here we have ICE plot. So this is basically a plot that determines if you change the features like age or gender and see how the model performance change. That helps you to understand what kind of the biased behavior your model has, and in order for you to take action towards it. As interactive toolkits, today we don't really have time to go through them, but if you are interested, look into Interpret ML and Google's What If tools. Those are good interactive toolkits. Last, mitigate. There are many options. So previously a lot of companies were focusing a bit more on pre-processing. For example, like off-sample, down-sample, some of the data set, those are some of the pre-processing techniques. Pre-processing, in-processing, and post-processing, you can use a lot of open source toolkits on this. I'm just going to show you one example. This one is with Microsoft FairLearn. And they have this tool called Grid Search. This is post-processing, so this is not about modifying your model. Modifying your model, while you are having some weird performance, it's about after you already have the model that you determine how do you pick a model that's not biased. In this plot, you can see a DPT score on the y-axis. You want the DPT score as close to 0 as possible. And in the x-axis, you are seeing the accuracy score. Technically, if you're a client, don't care about bias issue, things like that, they will want the accuracy score to be as high as possible. But that might not be ethical. And we don't want to be like that. We want to understand if we can generate a model that provides good enough score, but also have low enough DPT score. So this helps you to select the model that makes sense. There's also some of the toolkits. Again, I'm not going to show you this, but there's Azure Responsible AI Toolkits. Feel free to watch the video. You can still hear me, right? Communicate. Communicate is very, very important. Why? There's some risk can associate with communication itself or lack of communication. When you are working with your client or stakeholders, they might have some assumption without telling you. And you don't have the domain knowledge, so you don't really know. And they might be like, hey, here's the data set. And that's just going to help you to build your model. They didn't tell you the data set is only collected from certain race or certain region. So there can be some assumption made that makes your model more biased than it will be. Some companies might have decisions that's against the best practice of responsible AI. Unrealistic performance expectation. You might have some client or company, they just want the model to perform as high as possible and don't care about any of the ethical concern. What's the answer? The company I'm working for, AutoML, we have this framework that we're trying to follow. This framework, Model Craft, is from Google. Google have this Model Craft documentation that it's a framework, it's not necessarily some fancy toolkit. It asks people, whichever model you build, you need to write like intention use, why you are using this model, right? And the metric being used, what kind of data you have to use, limitation and ethical concerns. So the company I'm working at, we actually enforce this on all the model we build on all of our projects. Finally, I won't talk through the whole thing, but feel free to take a picture. This is some of the comparison with some of the big players in responsible AI. Microsoft's FairLearn, Google's What If tool, IBM's AI F360. They all have their own pros and cons, so you can look at them yourself. There was also Aquitas. It was user-friendly, but it was built by just a group of researchers, so they didn't really have that much funding, so tools are not as well maintained. So the very first three might be your best option if you are just very curious in this area. There are also other toolkits, not just this few, but these are some of the big players. Final words. As you can see, it's still early stage. We've been talking about the bias in human society so many years. But with the AI, bias in AI, it's still early stage. A lot of toolkits I'm just showing you, they just recently developed. And also mostly from the US, right? So the bias and ethic and all those things based on the US standards and North American standards. Another problem is many toolkits focus on group bias, not as much on individual bias. Previously, I mentioned the group bias, group fairness metric versus individual fairness metric. It's easier to build toolkits to address the group bias issues, less on the individual bias, but doesn't mean it's not important. A lot of toolkits focus on the classification more than regression, so that's one of the issues as well. And next, not enough AI practitioners are familiar with this topic, which is the reason we are here. We wanted to talk about it. I'm by no means an expert, but we are here to talk about it so we learn it and make sure that when we, as AI practitioners, we take into this consideration. Another problem is there are some technical people are familiar with these topics and are able to use those toolkits. But if you remember those slides I was showing you, there's a lot of technical terms, right? So we do still need to build software that's tailored towards non-technical users to make sure responsible AI is not just for technical people, it's for everyone. Conclusion and recommendation. So this one's more like my own recommendation. You might have your own recommendation after you dive deep into this topic. We need to treat data and AI just like human. It can just be as biased as humans do, if not more. We can never assume models won't be biased just because they are machine. There's still limitations. Even if you utilize some of the toolkits, use model card to do documentations, we never wanted to assume bias is not there anymore. It's just like in the human society, there's bias, right? And we're trying to address it, we're trying to solve it, but doesn't mean it's not there. It's still there. It's hard to completely eliminate it, but doesn't mean that we shouldn't focus on it. The more the reason we need to work on it. Communication and education will be key. So after this point, you can talk to your friend, talk to people you know about these topics, and maybe you can be one of the researchers to focus on this area as well. It's encouraged that all of us to pay more attention to this area because AI, machine learning, it is, as I speak right now, it is changing the way we live. Because all of you, the reason you are here is because you're smart, and the reason you choose this room because you care. Utilize your skills to make the world a better place. Thanks, everyone. I only have 3 minutes. Any questions? But no hard questions, please. Yeah, I think that's everything.
I got a question.
Yes.
Could I get you to go back to the slide with the scatter plot and the accuracy and the metric on discrimination? Yeah, this one.
Yeah.
So if I'm a potential client of Alpha ML and I've got a stack of 100,000 resumes that I'd like you to apply an algorithm to and tell me who by some predictive metric is going to get promoted in a couple of years, to me this says that I have to choose a trade-off with current models.
Yes.
Meaning its accuracy and its discrimination. I think that makes sense because current models would be based off of a biased historic hiring practice. Is there any efforts that you know of either internally or externally to try to create a sort of sampled version of those data sets that helps to eliminate this bias and makes this look like more of a random distribution?
Yeah, so there's actually different ways to address the bias. So this method itself is more about post-processing. So you already built a model. So that's actually a good question because there's limitation with this. The good thing about this is it's easier. You don't have to do anything to rebuild the model, right? But the bad thing is there's limitation how much bias you can remove from it. You're not really removing a bias. You are just picking the model that's less biased. There's also pre-processing is you address the issue during the data processing process. You can do some of them are pretty easy, even just up sample, down sample to make sure your data distribution in the sample data size is the same as the real distribution of the population you're trying to understand. In processing, there's some toolkits you can use to do that. In processing, it's about they will try to build model, but while it's building the model, it has two metrics trying to optimize. One, the DPT score, the metric score to be as good as possible while your model performance is good. So you can do that during the process as well. Any other question? Thanks for the question. Good question. All right, that's from me for today. Thanks everyone for being here. Really grateful to be here. And we'll talk to you maybe next time.